In this video, we will be looking into shift instructions. So there are two shift instructions we are going to see. Shift left logical, in short you can call it SLL. This is the app code. Shift right logical, SRL. Shift right logical, shift left logical. So first of all, let's look into SLL. Okay. So both the instructions, they are using to shift the content of a register. Shifting means you move the content to one side, either to the right side or to the left side. That's the idea. So this one to move the content to the left side, and this one move the content to the right side. Shifting the content of a register to the left side or to the right side. How many bits you are going to shift, you will write it in the instruction. So let's see the syntax. Write the app code and then destination register, and then you have source 1 register, and then here number of bits. How many bits you want to shift? You want to shift the content 1 bits to the left side or 5 bit to the left side, something like that. Let's see one example how the shifting will be done. So the idea is the source register, the content of a source register will be shifted this many bits to the left side, and the result will be stored in this destination register. That's the idea. Let's assume that you have a register, say T1 contains a value, for example 8. Then I'm going to have the shift left logical. So I want the result in T0 and the source register is T1. I want to shift 2 bits. So this is 2 bits. Let's assume. Okay. So assume the content of this register, source register T1, it's having 8. Okay, basically all the content of a register in MIPS are of 32 bits. Okay, so the content of T1 is 8. So 8 means in binary it's 1000. Okay, and let me write the content in 32 bits. So when you count the bits, you will see 32 bits. Normally MIPS architecture, the register's capacity is 32 bit. Okay. So now the instruction says content of T1 will be shifted to the left side by 2 bits. So you will be shifted to the left side by 2 bits. So this last 2 bits will be removed, gone. So these last 2 bits will be deleted. And remember, you need to keep 32 bits here. So 2 bits are gone. So how many bits you will have? 30 bits. Normally you need to have 32 bits. So you will have 2 additional space which will be filled with 2 zeros. Okay then. So this is the idea. So what will be the result? The final answer which will be stored in the destination register T0. This 2 bits gone because I am shifting to the left side. So 2 bits by 2 bits. So this 2 bits gone. So this 2 bits are kept in the register, and this 4 bits stay back, and these bits stay back, and this bits also stay back. This is 1 by the way, and you have 2 additional spaces because what I have is 30 bits. I need to have 32 bits. So this 2 additional bits you will fill with 0 by default. So how many bits you are shifting, that many bits will be gone in the most significant side. So in most significant side, those bits will be gone, and new zeros will be added in the least significant. So 2 means 2 zeros will be added in the least significant bit. Okay. This is the idea of shift instruction SLL. Now let's move on to SRL. SRL means shift right logical. So let's see the syntax. Same syntax like SLL. So you write SRL, destination register, and then you have source 1 register, and then again number of bits. How many bits you want to move to the right side? Remember, now it is to the right side. The same of SLL, but it will be in opposite. That's the SRL. Let's look into one example. Assume a register T1 contains a value 8. Now shift right logical. I want to shift T1 and the answer I'm going to keep it in the destination register T0. T1 is the source register. Let's use the same 2 bits. I want to shift 2 bits to the right side. Okay. So let's have the same content. You have 8. So it's 1000. Fill with the 32 bits. So when you count, you will have 32 bits. Now you shift to the right side. By how many bits? 2 bits. So right side. So these 2 bits will be gone. And here you will be having 2 new zeros. This is the idea. Okay. So the answer will be, I think the content of the destination register T0 will be, you have 2 new places. And then this one will stay back. This one will stay back. All other bits will stay back. Here 2 bits will be gone. So you will have 1 0. So let's fill this one with 0 0. You have 2 new zeros in the most significant bit because you are shifting by 2 bits. So 2 new 0 bits are added here. And here in LSB, you are shifting by 2. So 2 bits will be gone. I mean removed, deleted, whatever is it. Okay. So this is about the shift operations.